biggest thing that surprised me when I look at auto-instrumented applications is just how slow a lot of these frameworks are. Every couple of days, we're getting like a new benchmark on Next.js versus SvelteKit versus whatever. But in reality, it's completely detached from what you're actually doing, right? It's like not using your database. What's really interesting is looking at your own data and seeing, oh, my application is slow on this endpoint, and having really easy visibility into that. It really opens your eyes.
Hi there, and welcome to PodRocket, a web development podcast brought to you by LogRocket. My name's Paul, and joined with us today is Luca Casonato. He's a member of the Deno core team, and we're going to be digging into debugging apps, specifically with Deno and OpenTelemetry. Luca and I are going to get into how OpenTelemetry helps developers debug their applications running in production, how Deno's native integration with OpenTelemetry simplifies instrumentation compared to Node.js, and how developers can leverage it to improve their applications. So without further ado, here's our episode with Luca Casonato. Welcome to the pod, Luca. Excited to have you back.
Hey, Paul, thanks for having me.
So Deno is a JavaScript runtime. It's a little bit different than Node, and it has a lot of great benefits for rolling out applications quickly and probably, you could argue, way more secure ways than you might in traditional Node ecosystem. So if you want to learn more about Deno, we have Luca on here talking about it, and specifically some great stuff about the security layer. So go check those out if you want to learn more about Deno. But specifically like OpenTelemetry, right? This is like one tool that is tightly integrated with the Deno ecosystem. Can you talk to us a little bit about the history and like why that's exciting? Why are we talking about it today?
So OpenTelemetry is a tool for inspecting your applications, and not inspecting in the way that you might think of opening the Chrome inspector, but inspecting like a running application in production. So think of things like logs or metrics or traces. And I could talk a little bit more about what each of those are, because they're like each very important like foundational pillars of OpenTelemetry. OpenTelemetry consists of these three main pillars called signals, logs, traces, and metrics, that each serve a slightly different purpose, but altogether allow you to sort of understand what your application is doing. Being able to figure out when something goes wrong, why it went wrong. Like before that, even knowing that your application did, or that something in your application did go wrong, like being paged on a Saturday evening when your app goes down. That's a pretty important thing you want to have happen. And you can do that based on metrics, for example, out of OpenTelemetry. So what's new in Deno is that OpenTelemetry comes built in now, and we can generate logs and traces and metrics automatically for a bunch of things in the runtime. So the HTTP server, or outbound fetches, various other things, a console log, and automatically send those to your telemetry endpoints. So maybe you're using Datadog, or you're using with Loki, or you're using, I don't know, Honeycomb or Google Cloud Monitoring or AWS. They all support OpenTelemetry. So we can send our telemetry there, and then you can inspect your applications like in production through those systems out of the box.
What a great summary. I feel like we hit so many nails with one swing of the hammer there. So I think we are talking to a app developing audience here. I think a lot of people know what a log, a trace, and metric is, but there's folks that don't. Like, I mean, heck, I've been several teams over the past 6 or so years, and everybody's still discussing, okay, but is this a trace? Like, what is it? So could you give us a really quick rundown? Apologies if you think you already know it. You still might learn something from what Luca has to say about them.
Yeah. So logs and traces are sort of one side of metrics or of OpenTelemetry signals, and the other side is metrics. Let's start with metrics. They're a bit easier. Metrics essentially just count things. It's like how many requests have happened, or how many errors have happened, or how many requests have a 200 status code versus a 500 status code versus a 400 status code, anything like that. So metrics are just simple counters that inside of your application, you can increment when interesting things happen, and then you can get aggregate information out of those. For example, what's my percentage of failed success to successful requests? Without having to like individually track every single request, you just have two numbers. You have the number of successful requests in the last minute, the number of failed requests in the last minute. Divide those out, you get like a 1% error rate, for example. And then if that suddenly increases to 5%, you know something's wrong. So that would tell you you have to investigate. That's metric. And then you have logs. Logs, most people are pretty familiar with logs. It's like what you do when you don't want to use the inspector, right? You console log something, but logs by themselves have one big problem called context propagation, which means that when you print out a bunch of logs in a system that's parallel, so a system that is processing multiple requests at once, you never know which request those logs belong to. You could be printing out an error from the database or some information about the incoming request, but if you have two log lines, you don't know which two log lines belong to each other. Does log line with this database failure belong to request A or request B? Can't really tell that just from the logs. So for that, we have traces. Traces allow you to associate a bunch of information all with a single request. And really, it's not just a request, it's any operation. We associate them with something called a trace ID. There's a bunch of logs that can happen, events, spans is what they're called in OpenTelemetry, that all belong to the same request, and they can have some information on them, like there was an incoming request, it took this long, that made an outbound fetch request, 10 seconds into the request processing, that took 3 seconds. You can build a nice graph out of this. And this allows you to figure out, like, I have a request that's taking 30 seconds. Why does it take 30 seconds? Or I have a request that failed after 5 seconds. Why did it fail after 5 seconds? You can look at the trace and it'll tell you, hey, the fetch I made to the GitHub API failed at the end there. And that's something that you can do on a per request almost. Metrics are for when you don't really know whether something is broken or not, to tell you that something is broken just on aggregate data. And then traces you can use to investigate specific problems in your app by looking at individual requests and then looking like where inside of that request something may be slow or fast or broken. Yeah. And logs are sort of there, but if you have traces, you don't really need logs anymore.
If you have logs, you just need to instrument what is probably already instrumented. Maybe you have some additional logger statements and boom, you got logs. Look through them, scan through them, use your eyeball. Maybe you have fuzzy search. Metrics, on the other hand, that requires a little bit more configuration. Can you talk to us about what a typical Node developer might do to configure metrics for, I don't know, an Express application? Use another example if you want to.
Yeah.
And then similarly for like traces, what that lift is.
Yeah. Generally in Node, if you want to instrument this, you first have to find a instrumentation library that's specific to your telemetry vendor. For example, you're using, I don't know, Datadog. You would download the Datadog SDK, put it into your package.json, install that, and then you have to run some setup code before the rest of your application starts to instrument things. And that could involve 10 lines of configuration and saying I'm using Express and like importing the Express adapter and like all kinds. There's like setup you have to do to configure Datadog to know that it's meant to instrument Express. And then it could maybe have some out of the box metrics for the Node HTTP server or for Express, but only after you've done all this configuration. And then if on top of that, you want to add your own metrics, you have to import something from the Datadog SDK that lets you create a new counter or a new histogram or some other metric object. And then you can create that at the top level of your app and increment it or record things wherever you want to in your application.
Just to be clear, the way that kind of bubbles down is either Datadog is expecting a metric because Node works in this way. So we're going to have this little counter ready for you if you instrument it, or you can go to their app layer and say, make this bucket, make this ticker. Then when you configure it, you need to make sure it's instrumented before you build. And then if there's custom metrics, you need to make sure you put those into the software using their SDK so that it calls home to that ticker that they provisioned for you.
That's right. Yeah.
Okay.
And compare that to how that works to Deno. So in Deno, you don't have to install any SDKs. It comes out of the box and we automatically instrument a whole bunch of different things in the Deno runtime. Right now we instrument the HTTP server and outbound fetch, but in the future, we're also going to instrument the garbage collector and like various other things that may cause problems in your app, maybe the file system, things like that, the cache. And the only thing you have to do is set your endpoint where you want to export traces to. And OpenTelemetry just provides a like public URL, for example, that you can set in there. And maybe you have to put in your API key as well in a header. And you just set that up through two environment variables, and then you start Deno and run it normally. And there's no JavaScript configuration for this at all. It just works out of the box. And then if you want to do custom metrics, you can also do that. And that actually works pretty similar to how it works in Datadog. You add the OpenTelemetry API SDK to your Deno.json or your package.json, and then you can import that in your code and create your own counters. And you can give it a name and a description and a unit and whatever, all inside the code. And you don't have to configure anything else elsewhere. It just goes and exports those things right under your code. You just have to set the URL in the header, for example, or Datadog or like Honeycomb, whatever.
Now, I mentioned the security features of Deno at the beginning of the pod because they're really cool. And if you don't know what I'm talking about, go listen to our pod and check them out because it could be a new way to develop JavaScript in the backend responsibly. But I more importantly mention them because It's fundamentally a different way that Deno works with the underlying metal server or whatever server you have under the hood. And so there's different information that might inform how your application's running. So through that lens of the ways that Deno runs differently than Node, what type of stuff could a developer expect from the instrumentation that you think might speak to that difference that highlights the different way that Deno runs?
Yes. One thing that we could do, for example, because we audit instrument traces, is you have a way to get an audit log out of every IO operation that happens from your server. So if you make a fetch, that gets recorded as a span in a trace and gets exported to your telemetry endpoint. So you can tell who makes what IO operations when. And it also allows you to, if you do restrict your permissions using the Deno permission system, it lets you figure out at any point you're like over restricting. So if you're making a fetch call that fails, for example, because of permission error, you can tell very easily because the trace span will be an error and the error type on it will be permission denied or not capable or something like that. So it's pretty easy to figure that out. And then the other thing is because the instrumentation is built right into Deno, your application doesn't, you don't actually need to provide Deno with like permission in quotes here, like the allow net flag, for example, to talk to Datadog, because that's something that like the internal runtime does. It's not something that you have to do in user land. Like you don't have to manually call a fetch, make a fetch call to Datadog to record some trace or something. It happens all internally. And that allows you to run, I'm not going to say like untrusted, but like lower trust code and still have this telemetry because you can be relatively sure that the application itself cannot send random garbage to your telemetry endpoint, but it can only send things. No, Deno is the one that's actually sending the things to your telemetry endpoint. And there's multiple layers of like data sanitization that happened before Deno sent that out. You have a layer in between there where you could be relatively sure that not like complete and utter garbage is coming out of your process and going to your telemetry endpoint.
Bringing the telemetry layer one stop deeper, which is like into the Deno runtime versus as a plugin from what would be a similar stance of another package you just bring in. Does that bringing of it one stop deeper what was there like internal debate on the Deno team about is that a good idea or not? And I'm sure there was. Could you share with us like one of the concerns that people might have brought up and something that may or may not change in the future in the way we interact with that?
Yeah, this was definitely a consideration, but ultimately we decided that it was like overall better to have this a layer deeper. First of all, it gives us access to more data that we may not otherwise have in the runtime itself. For example, take like GT timings, like how long does it take to run the garbage collector? This is data that we have in the runtime, obviously, because the runtime is the one that's doing the garbage collection, but it's much more difficult to expose that to JavaScript in a performant way. So there's that. And then there's also the consideration of you want this to work in an environment where permissions are constrained. And if you do something in the runtime itself, it doesn't have to follow the same security or permissions that you may have imposed on your user code. Saying all of that, it is a mix, right? There's one, the actual thing that's built into the runtime. But as I said before, you can import OpenTelemetry/API and fit your own metrics. So there is a layer that sits in the runtime itself and interacts with runtime libraries that you can just pull in from NPM through some standard API. So it's sort of a mix. For the things that are really like security sensitive or performance sensitive, or like just need to access data that isn't available in JavaScript, we do things in the runtime. And then for cases where like you do need to interact with JavaScript, because like you're creating your own metric, your own span, your own logs, whatever, that obviously happens in JavaScript and users do get access to that.
When we talk about needing to configure your own span or set of traces you might be interested in, that might feel daunting to folks, especially when you're used to reaching for the Datadog SDK and you're dropping into Express and it just like works. Sentry is really great at that too. And they use AI now too to look at the correlated trace IDs. Where does Deno sit right now for that auto configuration instrumentation? And is there any plan to expand that? Do you feel like it's in a good spot now and you guys are like letting it bake with the community?
Yeah. So we try to instrument as much as possible with spans and traces out of the box. So take, for example, the HTTP server. When you start an HTTP server in Deno with serve, it'll automatically create a trace for every incoming request, and it will pick up on the trace parent header and do the propagation correctly. It'll automatically create a span that has the HTTP method and the URL and the status code and like the response body size and like all the things that you may reasonably want to have from like an HTTP server span. It has all of those baked in. And it does the same for outbound fetch and a couple other things, including for all our node compatibility things. So if you're actually using Node HTTP server from Node :HTTP, that also all works with it. But then there are cases where we cannot do that. For example, Deno doesn't have a built-in API to talk to, I don't know, MySQL, right? For those things, you either have to use a database library that has instrumentation, which is not unlikely because the way that you set up your instrumentation in Deno is through OpenTelemetry API, which happens to be the standard way to do custom telemetry in JavaScript. It's like the default OpenTelemetry SDK. Also, by the way, under the hood, that's the thing that Datadog and like a bunch of other things also use. So it's pretty widely adopted. But for those cases where you do not have any auto instrumentation and you're not using a library that's instrumented, you have to create the spans yourself. And what that entails is calling span dot, I don't remember, create span or something. I don't know. Look in our docs. We have great docs on this. And that'll just create a span with a name. You can set some properties on it. You can say whether it errors or not and run your code, and it'll just like work. So it is a bit annoying in the case where you need to create your own span, but it's getting there. And I think we are seeing a lot of other projects now starting to automatically instrument with telemetry. For example, Hono, the middleware framework, is getting a new OpenTelemetry middleware pretty soon that I think as part of our OpenTelemetry work in Deno, we pushed that a bit to happen a bit faster than otherwise would have. So we're definitely seeing movement in the ecosystem there.
Luca, sitting at the position you are in the team you're at, which is like intimate familiarity with the way that JavaScript can run, whether that be in Node, whether that be in Deno, you guys have been on both ends of the stick. Now you're looking at helping developers across the globe bring up and surface information for your runtime. And you've studied the other runtime. We've been talking about it this whole podcast. Given your familiarity with these metrics, these logs, these traces and spans that folks might have access to, of course, people will be able to view things like, hey, garbage collection. Now I can just easily do that in Deno. That's something I didn't have visibility into before. Are there things, be it performance, general optimization, software design, tech debt, any of these categories where you think devs have shoved under the rug or just didn't have the faculties to pay attention to because, hey, I have to make a custom span and now I don't need to in Deno? Are there any things in that category that you're just like, wow, people are going to be aware of X, Y, Z and they weren't before?
Yeah, I think the biggest thing that surprised me when I looked at auto-instrumented applications is just how slow a lot of these frameworks are. And I feel like every couple of days we're getting a new benchmark on Next.js versus SvelteKit versus whatever. And these are like sort of abstract, right? These are data that somebody has compiled based on what they think is a representative application that people may write. But in reality, it's completely detached from what you're actually doing, right? It's not using your database.
Telling us they can solve GitHub issues.
Yeah, exactly. Yeah. It's interesting. But what's really interesting is looking at your own data and seeing, oh, my application is slow on this endpoint and having really easy visibility into that. I think it really opens your eyes sometimes. There's one thing hearing people say, oh, look, this site was slow for me last Friday. And there's another thing where you have a metric that says 50% of users are seeing that this URL takes longer than 600 milliseconds to load, right? That's very concrete data. And if you improve that, you see the graph go down. It's very rewarding as well because you can immediately tell when some performance work that you're doing, for example, has an impact. It's sort of only really been reserved to teams in large companies that have had this sort of telemetry set up in the past and not to the random developer that's building a side project or something. Because historically configuring OpenTelemetry has just really been very annoying. So I'm hoping that getting this out to more people's hands will really give people the tools to figure out why their applications are not performing well or what they can do to make them perform even better.
Okay, we had a good walk around the block with logs, traces, metrics, and how they're going to be plugged into Deno at this deeper layer. That's really neat. And just to reiterate, Luca, you said that these are all going to be pluggable, not just into your own OpenTelemetry API, but Datadog, Google Cloud monitoring.
Yeah, so we support anything that can ingest OpenTelemetry protocol. So that's the standard protocol for getting telemetry data from applications into these telemetry services. For example, Honeycomb or Google Cloud monitoring, they support this out of the box. With Datadog, you have to go through the agent, but they also support this. And you're using something like Grafana with Loki or Tempo, whatever, the Grafana stack. You can also just use this out of the box. I'm probably forgetting some telemetry systems right now. I think
that's
Sentry
great.
supports OTLP as well, but essentially everyone supports this. This is the standard protocol.
Awesome. Just wanted to like cement that down in case people were wondering what it's compatible with. It's basically everything, guys. It's OpenTelemetry. Okay, so we're going to go into the thing we've been wrapping up episodes with called the quick round, Luca. These questions may or may not make sense. The purpose of them is to just like elicit a reaction that might elicit other people's reactions. It's supposed to be like naked from your brain, right? So I'm going to run through these and just try to make as succinct of an answer as you can. No worries if it rambles on though. What's something you've had to debug that was extremely frustrating? Maybe you were allergic to looking at your traces and stuff, and then you finally looked and you were just like, that's what the bug is. It was so frustrating and you wanted to slap yourself in the face. Could you tell us like one of those?
Yeah, absolutely. Actually, this one's completely unrelated to telemetry, but 2 years ago or something, we had a problem internally where there was two services that were talking to each other with HTTP2. And HTTP2 has this fun thing called byte window size. I don't know. I forget what it's called. Like the maximum number of bytes that could be in flight at any point in time. And we had a deadlock here where the server and the client were disagreeing on the window size, and one was sending less than the server was trying to process, whatever. The ultimate problem was like, you would send a request and it would just get stuck, right? And it just wouldn't arrive on the other side, or some data wouldn't arrive on the other side. And I spent a week, like I mean it, like actual weeks trying to figure out what this problem was. It ultimately was like just a stupid misconfiguration somewhere. I wish I had traces to figure that out, but yeah, it was really terrible.
Man, that's like a head scratcher because I'm sure there's not a ton of tooling and pre-existing prior art around there of debugging your context window size.
Yeah, it's like TTP dump and like Wireshark is you have to get out that.
Maybe you're up that alley of thought. Maybe you're thinking about this experience. Maybe you're looking at other experiences of now having OpenTelemetry auto-instrumented into the runtime. What's something you wish every developer knew about debugging, looking back on these experiences and tools?
I think the value of knowing why something is happening, like usually people debug with logs, and logs are really nice if there's one thing happening at a time because you can just follow the time order, right? The thing happens first, this thing happens second. But then the fact that you have multiple things happening at once, it becomes really difficult to track that. So if you can associate your logs with a specific request, it makes debugging so much easier because you don't have to guess about which log belongs to which request. It can tell you if you've associated that. I guess the answer is go put traces everywhere because I guess traces are that.
What's one thing you check when something breaks in production? First line of things to check. And this is up the same alley of what's something you wish developers knew about debugging. What would you suggest people go check? Obviously, it's situation dependent, but
I feel like the obvious answer here is check that your DNS is correct. But I think we're the funny answer.
But like,
it's true.
Sure.
How many times is it the DNS, right? No, I think, I don't think there's one thing that you can point to, but I think having like a good understanding of what your code base is structured like can really help because if there's, for example, something that is taking a long time in a specific request, it's really useful to know like what things that request is doing. If it's only making a database call and it's slow, 9% chance it's the database that's slow, right? And not anything else. Like having a good understanding of what approximately your code is doing is pretty useful, which I think that makes sense, right? Like you probably want to know what your code is doing, but I think in the age of AI, it's worth reiterating.
I was about to say, it's gotten a bit tougher these days because we're all like hybrid vibe coders sometimes, depending like how much boilerplate there is.
The other answer to that is keep your code slim, right? Don't over abstract because if you have a lot of abstractions, it's more difficult to figure out. Less abstractions means less things that can go wrong.
Oh, Luca, it was awesome talking about OpenTelemetry, like revisiting the fundamentals and then like talking about what's going on with Deno. We love keeping up with you guys and in your team as you guys just keep innovating. There's like more and more like extra things that make Deno just a little bit of a different flavored ice cream than Node. So please keep us in the fold. And hopefully we'll keep having you on the pod. So folks who like to listen can listen in and learn what's going on. If people want to particularly keep up to date with you, I'm sure if people wanted Deno, you could go to deno.dev. Everybody knows this. We can link in the show notes. But for you, Luca, specifically, are you more of a Blue Sky person? YouTube, where can people find you?
Yeah, you can find me on Blue Sky or my website, lcats.dev. But yeah, my Blue Sky is linked from there or on Blue Sky, same handle.
And the website was LCAS Dev, right?
Yes.
Awesome. Thanks again for coming on, Luca. Thanks for your time. It's been a pleasure.
Thank you so much for having me.